Alright, these problems that we're going to do today are going to be about finding zeros and factoring. And then towards the end we'll do some where we have the zeros and then we're going to come up with the polynomial. So for this problem, which is the first problem, I'm going to put this equals y1. For any other problem, I'm going to have y2 equals 0. So just leave y2 equals 0 for pretty much the next set of problems, anything we do in the graphing calculator. So when I graph this on the calculator, this is what the picture looks like. What we're going to do is we are going to do second calc, and then we're going to do 5 for the intersect, and then you want to hit enter, and when you have to guess, you want to move it around. So one of my answers was negative, that was a -2. My first answer over here on the far left was -3. Then that answer was -2. And this answer was +2. So x equals -3, x equals -2, and x equals 2 were my three answers. And that makes the factoring pretty easy. So with x equals -3, x equals 2, and x equals -2, I get the answer of x plus 3, x minus 2, and x plus 2. And so here are the zeros, and here are the factors. For the next problem, we're going to try this one. And we're going to put that into y1, and let's see what the graph looks like. Alright, so when I try to do this, and I try to find this answer on the left hand side, it keeps on jumping back to this problem, which is x equals 1/2. So I know 1/2 is one of my answers, and so we have to look at what this looks like, and so it looks like -3. So when I hit second calc, second trace, so second trace 5, I hit enter, and then enter again, and since my guess is -3 and it won't show me if it's -3 or not, it turns out to be -3, and the calculator agrees with me when I guess -3. And what I said yesterday is that anytime we have a situation like this, that is called a double root, which means I have -3 and -3. So these two answers are really easy to take care of because that's x plus 3 and x plus 3. But the other one is x minus 1/2, which doesn't work. So what I'm going to do here, because I don't want to have fractions, is I'm going to multiply by whatever the denominator is, which is 2. So that means that we get the answer of 2x minus 1. Now if you want to check to make sure that this is right, what you can do is you can graph this in y1, and we left y2 as 0, and if you graph this in y3, you will still only see one graph because these two graphs are actually the same thing. Alright, my next one is going to be x to the cube, x to the third, minus 4x squared, minus 4x plus 7. And when I use this photo, when I use this graph, this turned out to be x equals -1 point blah blah blah, and this turned out to be x equals 4 point something something. But the only one that made any sense was x equals 1. Now these, even though they were decimals, didn't work out to be any fractions that we know, so the only one I know for sure as an exact answer is x equals 1. So when that happens, I'm going to divide by the 1. 1 times 1 is 1, -3, -3, -7, -7, and 0. And so we're not going to factor this one because we don't generally factor when we have to use the quadratic equation on a problem like this. So we got negative b plus or minus b squared minus 4ac divided by 2a. So two negatives make a positive. 2 times 1 in the denominator. Square root of negative 3 squared minus 4 times 1 times 7. Now when I put this in the calculator, I'm just putting that part. So we got 3 plus or minus something divided by 2. And of course this should have been negative 7, not positive 7. So we got the square root of 37. Because we cannot break down 37, my answers are x equals 1, x equals 3 plus the square root of 37 over 2, and x equals 3 minus the square root of 37 over 2. And since the top exponent over here is 3, we get 1, 2, 3 answers. Alright, the next one we're going to try is x cubed plus 4x minus 16. And so we're going to put that into y1. And this one only has one zero that we can find, and that turns out to be x equals 2. So what I'm going to have to do for this one is I'm going to have to divide. I do 1, 0, 4, negative 16. The 1 drops straight down. 1 times 2 is 2. 0 plus 2. 2 times 2 is 4. 8, 16, and 0. I'm going to plug in the quadratic equation. B is 2. A is 1. 2 squared minus 4 times 1 times 8. So we get negative 2 plus or minus the square root of is negative 28 over 2. So I'm going to break down 28 here for a second. 7 times 4. 2 times 2. Don't forget about the I because we're doing a negative over 2. Now each one of these 2's are in each one of them. So I got negative 1 plus or minus I square roots of 7. So if I had to factor this, I had x minus 2 from above, x plus 1 minus I square roots of 7, and x plus 1 plus I square roots of 7. And that's how you would factor this. And we got the 3 zeros right here. The last one of factoring that we're going to do is this one. I'm going to do this since this is x to the fourth and x to the second and just a number. I'm going to try and factor first. X squared and x squared. What two numbers multiply up to be negative 36 and add up to be negative 5? Well, negative 9 times 4 equals negative 36, and negative 9 plus 4 equals negative 5. So here we got negative 5, and here we have, not negative 5, negative 9, and positive 4. In this one we have the minus sign, which is the one that we don't need I for. So we break down x squared to be x and x. One's plus 3, one's minus 3. Over here we have the plus, which means we have to have the imaginaries in there. So the square root of 4 is 2i. One's minus and one's plus. And here's the factors. And the zeros are easy because that will be negative 3 and positive 3 and negative 2i and positive 2i. Alright, so let's say that we're doing the opposite type of problem, which is we've given the zeros and now we need to get back to the other part. Well, we're going to have to multiply three things together. For that one, we're going to need x minus 3 and x minus 2. When we have a fraction and you think it should be x minus 1/3, I don't want to deal with fractions, so I'm going to multiply by whatever the denominator is, which in this case is 3, which means we'll have 3x minus 1. So how are we going to multiply these together? I am first going to multiply these two because you can only do these two at a time. X times x is x squared minus 2x minus 3x plus 6, which gives me an answer of x squared minus 5x plus 6. But I need to multiply this by 3x minus 1. So here's x squared minus 5x plus 6 times 3x minus 1. So 3x times x squared is 3x cubed. X squared times negative 1 is x squared. Negative 5x times 3x is negative 15x squared. Negative 5x times negative 1 is positive 5x. 6 times 3x is 18x, and 6 times negative 1 is negative 6. So we got 3x cubed minus 16x squared plus 23x minus 6. Sorry, so we have 6 and we have 1 minus 2i, which means I need to include 1 plus 2i, which means I'm going to need to multiply together x minus 6, x minus 1 plus 2i, and x minus 1 minus 2i. And when I first multiply, I'm going to take care of these two first, because when I do, all of the i's should disappear. So x squared is x times x minus 1x minus 2ix minus x plus 1 minus, plus 2ix negative 2i and negative 4i squared, which is really positive 4. Negative 2ix and positive 2ix are gone. Positive 2i and negative 2i are gone. And so we're left with x squared minus 2x plus 5, which I'm going to multiply by x minus 6. So x minus 6, x squared minus 2x plus 5, that's x to the third, minus 2x squared, plus 5x, multiplying negative 6 times x squared, negative 6 times negative 2x, and negative 6 times 5, and we wind up with x cubed. Negative 2 and negative 6 is negative 8x squared. 5 plus 12 is 17x minus 30. Please email me if you have any questions.